Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video, guys, I'll be tackling question number 6 from the mid-year examination, which was written in the year of 2024 and also in the province of Eastern Cape. Please do note that, guys, there will be 9 videos in total, since the question paper consists of 9 questions in full, and each and every one of these questions have their own video. So please, guys, do take this seriously, because I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your examination. Yes, we are preparing for the mid-year exam now, but you will have an edge whenever you write your mid-year exam, preliminary exam, and most importantly, your final examination. So please do share the video to your peers so that they may have the same edge as you. And please, guys, do help us grow the channel by just subscribing. Nah? Okay. The diagram below shows a boy the diagram below shows a boy skateboarding on a ramp which is inclined at 30 degrees to the horizontal. A constant frictional force of 50 newtons act on the skateboard as it moves from point A to B. Consider the boy and the skateboard as single unit of mass 60 kg. Ignore the effects of air friction. Okay. Firstly, guys, an errata was provided by the examiner, and the examiner indicated that the initial velocity of the boy was 0 meters per second. Why? Because initially the boy was stationary at position A. Are you together? Yeah, that was the first thing that I wanted to highlight over there. Okay. For us to be able to do calculations over here, guys, we must know the distance traveled by the boy from position A to B. Né? But luckily, we do know trigonometry. There is a trig ratio that has a relationship with both the side opposite to the angle and our hypotenuse. Né? I know that sine of 30 degrees will be equal to 10 all over delta x. Let me call that delta x, ne? But we do have delta x. Okay, let's call it just the distance traveled. So this is 1 over 2 is equal to 10 all over d. Cross multiply, then the distance traveled will simply be 20 meters. So the distance from position A to B, that's 20 meters, ne? Okay. Now they want us to draw a free body diagram showing all the forces acting on the skateboard while it is moving down the incline. Okay. The boy is on top of a skateboard and they both have a mass, so they do have a gravitational force. Both of them are on top of a surface, so they do have normal force, which is always perpendicular to the surface, and then they do have a frictional force as well. Fk, weight, and normal force. You can draw a free body diagram that shows the components of gravity. You'll still have your kinetic friction. You'll still have your normal force, which is always perpendicular, Fk, and that's normal force and kinetic friction. And then you'll simply have your Fg parallel as well as Fg perpendicular, right? Fg parallel, guys, is always equal to mg sine theta, and Fg perpendicular is always equal to mg cos of theta. Ne? The theta is just the inclination between the horizontal and the inclined surface. Okay, now we've drawn the free body diagram. They want us to use energy principles to calculate the speed of the skateboard unit at position B. Okay, their speed at position B, since you are not forced to use work energy theorem, we can use the work done by non-conservative forces, ne? Because we do have a non-conservative force over there, and that's our constant frictional force of 50 newtons. That's a non-conservative force. So what will happen over here? We'll simply have the work done by non-conservative forces being equal to the change in kinetic energy plus the change in potential energy. Since we only have one non-conservative force over there, I'll simply say this is just work done by kinetic friction being equal to half mv squared final minus half mv squared initial plus mgh final minus mgh initial, ne? But remember that, guys, the work done on an object, ne? Let me write this over here. Work done on an object by any force, it will be equal to the force in question multiplied by the distance traveled and cos theta. If I want to find the work done by kinetic friction, that means I must use the kinetic frictional force over there. All together. So I'll simply multiply my kinetic friction of 50 newtons with the displacement traveled. The displacement, we found it to be equal to 20, and then this will be simply cos of 180 degrees. This theta just represents the angle between the force in question and the direction of motion. Friction is opposing the motion, so that means friction will be acting up the incline, while the direction of motion is just down the incline. So the angle between the two is just 180 degrees. Okay, this is equal to that's half mv. The mass of both the skateboard and the boy is 60 v squared minus, initially the boy was at rest, or the boy was stationary. So the velocity initially was 0 meters per second, and hence the entire kinetic energy will be equal to 0 joules. Then finally, whenever the boy and the skateboard reach the bottom there at position B, the height above the ground will be 0 meters. So when the height above the ground is 0 meters, when the height is 0, it simply means potential energy is also 0. So that's minus what am I doing now? Plus 0 minus, and then the initial potential energy, that's basically 60 multiplied by g multiplied by height. The height was just 10 meters, ne? And then on the left hand side, I'll have 50 multiplied by 20, 50 by 20 multiplied by cos 180. That's basically negative 1000 is equal to 30 v squared. And then I'll have 60 multiplied by 9.8 multiplied by 10 minus 5,880. So whenever I take the 5,880 to the other side, it will be positive. I'll end up having 5,880 minus 1,000. This will give me 4,880 is equals to 30 multiplied by v squared. I can divide both sides by 30. Then v squared will simply be 488 all over 3. Then I can take square roots on both sides. I can take square roots on both sides, and then my final answer will simply be 12.75 meters per second. So the answer there, the speed of the boy skateboard unit at position B is just 12.75 meters per second. Okay, and then now you're told that point C is x meters, or rather is delta x meters to the left of B. The boy skateboard unit comes to rest at point C. The coefficient of kinetic frictional force for the surface BC is 0.15. The first question, they want us to state work energy theorem. Ne? It simply states that the net work done on an object, the net work done on an object is equal to the object's change in kinetic energy. Okay, and then 6.3.2, we are supposed to use the work energy theorem to calculate the distance x that the boy's skateboard unit moved before coming to rest at position C. They want us to find that horizontal distance of BC. Let's create room for us to write over there. Okay. Let's create room. Okay, now we are focusing on path BC, right? And on path BC, guys, we are told that path BC is a horizontal surface, so we do have our weight and we do have our normal force since we have a surface, and since there's no force that propels the boy to move towards the right, that means we only have frictional force which is acting horizontally. Are we together? And we can find the magnitude of our normal force. Ne? How can you do it of our kinetic friction? Remember that, guys, kinetic friction is always mu k multiplied by normal force. In this case, we are told that our mu k is just 0.15, but normal force is directly opposing the weight, so that means they are both equal. Are we together? So that will be just 60 multiplied by 9.8. So the magnitude of our kinetic friction is just 0.15 times 9.8 times 60. That's basically 88.2 newtons. Remember, we were told that the coefficient of kinetic friction is 0.15. Ne? So if I'm given the coefficient, guys, I must always go and find the magnitude of kinetic friction. And then now they want us to use work energy theorem to calculate the distance. Okay, we can simply use work net is equal to the change in kinetic energy. Ne? We'll only focus on the forces that are acting horizontal, are acting horizontally, ne? Because the ones which are acting perpendicular, they do no work on the object. So the only force acting there is just a frictional force. So this is basically work done by friction is equal to half mv squared final minus half mv squared initial. Ne? Frictional force, the magnitude of friction is just 88.2. We are looking for the distance traveled, delta x, and then there's cos of 180 degrees. Friction always opposes motion. Ne? Okay, finally, we were told that the boy unit skateboard will come to rest at position C. That means the velocity at C is 0 meters per second. Over there, we did find the velocity of 12.75 meters per second. Ne? So if the velocity at position C is 0, that means the entire kinetic energy will be 0 joules. That will be 0 minus 1 over 2 multiplied by 60 multiplied by 12.75 all squared. Ne? On the left hand side, we will have negative 88.2 rather times delta x is equal to negative half multiplied by 60 multiplied by 12.75 squared multiplied by 12.75 squared. This will give us 4,876.875. It's negative, by the way, né? So delta x will be equal to negative 4,876.875 all over negative 88.2. So delta x is basically equal to 55.23, rather 0.29 meters. So this distance over here is just 55.29 meters. So the boys skateboard unit will simply travel a distance of 55.29 meters before it comes to a stop. That's how, guys, we're supposed to tackle that question over there. So please, guys, stay tuned and wait for more videos. Danko.